Okay, today we're going to look at solving a system of equations that includes both a quadratic equation and a linear equation. Just a brief review real quickly. We've talked about quadratic equations quite a bit lately, and that's an equation that fits in the form of y equals ax squared plus bx plus c. It's a second degree equation, and it always makes a graph that will look very much like this in the form of a parabola. We're going to combine that in a system with a linear equation. Now, a linear equation we haven't talked about a lot lately, but we should be pretty familiar with. A linear equation is a first degree equation. The highest power of x in that type of equation is 1, so it's a first degree equation. And when you graph an equation that's in first degree, it always makes a line, hence the name linear equation. So what we're going to do is we're going to look at a system of equations. Now, if you're not entirely familiar, or you don't necessarily remember what a system of equations is, it's two or more equations working together with the same x and y values. They have one set of solutions that work for both of them, and that's our task, is to find the solutions x and y that will work or satisfy both equations. If we were going to look at the graphs of these two, we would put them on the same graph, and the solutions would be the coordinates of the points where those two graphs actually intersected. So sometimes it can be very useful for us to know the solutions to a set of equations. Of course, every point would have its own coordinates, x and y, and those would be the answers, or one of the answers in this case for this system. The other answer would be over here. Again, no guarantee that you're going to have two answers. You might have one answer. You might even have a scenario where you have zero answers to the problem. And we'll look at some special situations like that at a later time, but it is possible. At any rate, what we're going to do today is talk about how to find these points. We're going to do it algebraically. We won't be graphing, so we'll take a look at that now. Okay, so again, what we're going to be looking at is solving systems algebraically. In this case, we're referring to a system of equations that includes a quadratic and a linear equation. So in both of those cases, or in that case, excuse me, in that one case, what we're going to do is we're going to start off by making sure that both of the equations are set equal to y. So we would have to get y by itself in that case, or actually in both cases. A lot of times that'll already be the case and it's already set up that way. Other times you might have to make some adjustments, get things by itself. It's something that we should be pretty well at this time, or do pretty well with at this time. So once we get them equal to y, we're going to set the two equations equal to each other, because they're both equal to y. They're both equal to the same thing, so they must be equal to one another. And that's I believe that's the transitive property of equality, and we'll apply that and set the two equations equal to each other. So once we do that, we're going to get everything over to one side, just like we would in any other quadratic equation, because that's what we would have, and we'll solve for x. And we're going to do that by either using the quadratic formula or factoring, even completing the square if that's what you like to do. Once we do that, we'll take our values of x that we've gotten from our solution, we'll plug them into one of the original equations, and find y for each of them. And once we do that, we'll have an x and a y, or a y that goes with every x, that we have, and we'll write those solutions out as ordered pairs, an x and a y, which would represent those points that the graph has intersected in. So let's look at an example here. Now that you've got a chance to get all that down, let's look at an example here. We have a system that we're going to solve algebraically. You have y equals x squared minus 8x plus 28. That, of course, is our quadratic equation. And our linear equation is y equals 4x plus 8. Now we're saying that these are a system acting together. We're going to look at or look to see if we can identify the points at which these two cross over, or the points x and y that they share. So we're going to first make sure they're both equal to y, and in this case they've already been set equal to y, so we're good there. So the next thing we'll do is make sure, or set them equal to each other, excuse me. That would give us x squared minus 8x plus 28 is equal to 4x plus 8. Now in this case we've got one big quadratic equation, you can see. So what we're going to do is we're going to get everything over on one side, make it equal to 0. We'll start off by subtracting 4x over. That's going to give us, what, x squared minus 12x plus 28 on the left side. And over on the right side, we'd be left with the 8 there. And of course, we have to get that out of the way as well, so we'll subtract 8 from both sides. And we finish out getting everything over on the left side of the equation to have x squared minus 12x plus 20 equals to 0. Now that's our quadratic equation. It's set up and ready for us to solve. And again, as I mentioned earlier, you can solve this with a variety of techniques. We're going to use factoring here because this is a factorable quadratic, and it's pretty quick since it doesn't have a lead coefficient, or it has a lead coefficient of 1. We can easily identify the factors of 20 that are going to combine to make a negative 12. And if we stop and think, the factors of 20 would be 1x and 20x, 2x and 10x, 4x and 5x. The combination that we'll add to make negative 12 would be a negative 2x and a negative 10x. So we can use the quick method to factor this into x minus 2 and x minus 10. That's equal to 0 still, of course. And once we find that those are our factors, you can easily identify that x is equal to 2 or x is equal to positive 10. Now, again, we've already learned how to solve by factoring. I'm not going to spend a lot of time talking about the process there. Hopefully you remember how that's done, and if you need to, you can go back and look at some of our other videos. But once we found that x is equal to 2 or 10, we're going to now take those values and we're going to plug them into one of the original equations. Well, we have two original equations. Y equals x squared minus 8x plus 28 was the first one. The second one is y equals 4x plus 8. I'm going to take that second one because it's a little simpler, and we're going to say that x is equal to 2, and we're going to plug it into that y equals 4x plus 8. So basically all we're going to do here is take the equation that's given, plug 2 in for x, since we're saying that's equal to it, and we work that out and find out what y is. In this case, y would be 4 times 2 plus 8. So that is y is equal to 16. So we have an x of 2 and a y of 16. That identifies one of our solutions, and in this case that solution would be 216. The 2, of course, is representing x, 16 is representing y. Now, we had one other solution for x, so we're going to apply that one as well to find the other point. If x is equal to 10, and we take it and plug it into the equation y equals 4x plus 8, we would end up with y is equal to 4 times 10 plus 8. Y equals 4 times 10 plus 8, of course, is going to give us y equals 40 plus 8, or 48. So now we have a second solution for our problem, and that is y is equal to 1048. So we have our two solutions here that you can identify as the 2 points. They're both in ordered pairs to represent the coordinates, 216 and 1048. Now, we're going to talk about doing this again. We're going to look at another example. Here you can see we still have another quadratic, y equals x squared minus 9, and y equals 2x plus 6. There again, we have a quadratic and a linear. The quadratic does look a little different here. It's x squared minus 9. We don't have a linear term there. But they're both equal to y, so that means that we can set them equal to each other. So we have x squared minus 9 equals 2x plus 6. And again, we're going to get everything over on one side. So that would mean we're going to subtract 2x first. We'll subtract 2x from both sides, and that makes it look a little bit more normal. We have x squared minus 2x minus 9. Of course, on the right side, that would leave us with equals to 6. And we're now going to subtract the 6 over as well to give us a quadratic equation of x squared minus 2x minus 15 equals 0. Again, we've got everything over on one side. You can solve this using the quadratic formula if you like. Of course, a would be 1, b would be negative 2, and c would be negative 15. That's another technique that we're not going to use right now, but if you're comfortable using that, go right ahead. We're going to stick with factoring because that is the faster method, and when we can do it, it's as we can in this problem, it's a much easier method. So we can easily identify some factors of 15 or negative 15 that will combine to make negative 2. Factors of 15 would be 1 and 15, 3 and 5. And those are pretty much the only options you have. So we can see that if we take a positive 3 and a negative 5, we can easily get this to form a negative 2. So we'll break that into x plus 3, that's their positive 3, and x minus 5, which is your negative 5. So x plus 3, x minus 5 is equal to 0. At this point, we can easily identify that x is negative 3 or positive 5. So once we have those two solutions again, we're going to pick one of the equations out and plug it in. Plug in the negative 3 and plug in the 5. So we plug in negative 3, and I'll choose again the second equation because it's a little bit simpler this time. Y equals 2x plus 6. So we plug in negative 3. That gives us y is equal to 2 times negative 3 plus 6. So real quickly, you should be able to figure out that's negative 6 plus 6, and that would give us y is equal to 0. So the solution, or one of the solutions here, is the coordinate set negative 3, 0. We're going to find the other one by taking 5, which was the other value that we saw for x, and we're going to plug that into y equals 2x plus 6. So when we plug that in for x, y is equal to 2 times 5 plus 6, and that gives us y is equal to 10 plus 6, which is 16. So again, your solution is going to be 5, 16 here. So we have two solutions. These are the 2 points that these graphs would intersect at. Those coordinates would be negative 3, 0 and 5, 16. Okay, now I'm going to give you one to try. We have y equals x squared plus 5x minus 7, and y equals x plus 5. I'll give you a moment to pause here and try it on your own. Okay, now that you've gotten it, or you've gotten as far as you can get, let's take a look at what we would have done. Since they're both equal to y, we can set them equal to each other. We have x squared plus 5x minus 7 is equal to x plus 5. And again, we'll get everything over on one side, so it's equal to 0. So we subtract x, and that would give us x squared plus 4x minus 7 is equal to 5. And then we subtract the 5, so we have x squared plus 4x minus 12 being equal to 0. Once again, now we've got it equal to 0, we can solve this equation. You can use your method of choice. I'm going to again use factoring. So we're going to identify factors of negative 12 that we'll subtract to make 4. And the factors of 12, of course, would be, factors of 12 would be 1 and 12, 2 and 6, 3 and 4. And in this case, the ones that would subtract to make a 4 in the middle, a positive 4 would be negative 2 and positive 6. So when we factor this equation out, we'll factor it into positive 6 and negative 2. That's x plus 6 and x minus 2 equals 0. And using the 0 principle, we can apply that and see that x is equal to negative 6 or positive 2. And hopefully by this point you know the next step is to take those x coordinates and plug them into one of the equations. I'll probably choose the simpler one, which is x plus 5, and find out what y is equal to. So y is equal, or if x is equal to negative 6, we're going to plug that into y equals x plus 5. And that gives me y is equal to negative 6 plus 5, which is negative 1. So the solution for this set would be this coordinates, negative 6, negative 1. And we're going to go to the next possibility for x, which would be 2. If x is equal to 2, we plug that into y equals x plus 5, and we get y equals 2 plus 5, telling us that y would be 7. So if x is 2, y is 7. That would give us the second solution of 2, 7. Again, it's a pretty simple process, provided we know how to solve the quadratic. We basically set up our quadratic, solve it, take our possibilities for x, and plug them in to find the possibilities of y that go with them. Hopefully you got that one correct. If you're still having some problems, please feel free to speak with me. Otherwise, have a great day. Congratulations on completing the video.